And welcome to my channel. Today we'll talk about a rather obscure but at the same time seminal piece of software. It's EURISKO by none other than Douglas Leant, which is has a pretty special place among early artificial intelligence software. You see, Risco belongs to an obscure class of AI systems called discovery systems. The idea behind these systems is they operate in some predefined concept space using heuristic rules either handcrafted by a human or enhanced by the program itself, and they develop concepts in this search space that hadn't existed there before and make new discoveries about the isolated world they're exploring, finding out the rules governing these systems. And I don't think there were that many attempts to build such a program. The first one was AM, Automated Mathematician, by Leant as well, written by him in mid-1970s. It did some exploratory research in mathematics, in elementary mathematics and number theory, and with some attempts to apply it to geometry. And it is said to be have rediscovered primes, various factorizations, explored very big numbers in the spirit of Ramanujan work. And the other attempt was EURISKO, which was an extension of that work, in that this system could manipulate not just the concepts with predefined rules, but it could also explore and modify the rules based on the interactions, based on the results, how well the rules worked, and combinations of rules have worked on creating new concepts. So how does it work? Well, it's a complicated question. Basically, we have a huge Interlisp program. Well, this part is relatively compact. The core Risco system, it goes about the agenda and it makes use of different rules based on their assigned value, exploring new concept, suggesting new rules, and placing them on an agenda again, with their interestness being a combination of interestness of previous rules by some sort of mechanism. I think that's one of the part where Leant have explored a lot. So this is basically the start code. It's one loop which just cycles through agenda, initializes things, and if you are on an Alto system, or which is in this case, in our case, would be a Medley system, it would even provide you an option for graphical user interface. There is another file here, which is a sizable set It is 6.2 thousand lines of predefined heuristics that EURISKO starts off with. You can see it uses property lists to store it in a frame-like system, which is itself sort of like early prototype-based object system, but more with artificial intelligence in mind. It was popular concept at the time, both on the both coasts of the United States. Marvin Minsky is thought as a pioneer of that. I don't know to which extent it has influenced the work of Leonard, but probably there was some cross-pollination. So you can see here, this is an ESA rule. There is a value assigned to it at the start, and the various slots that are responsible for visualization and actual computation of the rule and dimensionality of the operation as well. This is the opposite rule, defined in terms of ISA above. So lots of concepts like that. So the result of this system was interesting. I think in the end Leonard has concluded that they worked much due to a predefined concept that he started, has programmed into the system at the start, and as such it was kind of a different form of data-driven programming rather than some magic achievement by artificial intelligence. So just that it was formulated in less deterministic way, so hence it could surprise the operator. But that gave a start to his further effort with RLL, representation language, which was thought to extend the Risco, and that became a start of Psych, his life effort to build a huge artificial intelligence system based along the same principles, which still continues today. And that is another chapter, but what we'll do now, we'll have a look at how this thing actually runs in a Medley system. Okay, let's have a look at EURISKO with Medley. We're running native Linux Medley as said. Here we get immediately into running an Interlisp prompt, placing the window strategically so that we have enough place for the upcoming UI, but also to see enough of the text that EURISKO logs on the screen. Now we're changing to the working tree of our EURISKO source, compiling the EURISKO file as per instruction, saying just no to everything. The screen goes inversed when it's pausing the scrolling. We're going to disable that so that EURISKO is free to scroll as long as it wants. So load in EURISKO, type in EURISKO to start. Running snazzy user interface. You can see the concepts, agenda, tasks, and heuristics view in it, 4 panes, and running the EURISKO proper. First time it will ask you to initialize everything. And it kicks off. We are whooshing past right into tasks in the 70s because the exploration space gets, I believe, substantially harder as it advances. It tries various hypotheses combining the rules, heuristic rules it has on the list with the tasks which are ranked by their importance. You can see in the bottom left the heuristics it chooses for current tasks and the agenda it explores. The concepts are mathematical in this setup. There was a version of EURISKO for a traveler competition for a tabletop fleet exercise competition that was using apparently a different set of the rules. And Leant is his work notes, and in his publications he mentioned that any work with EURISKO was a collaboration between man and machine. But you have to consider that it was running a lot slower on the Interlisp-D machines back in the early 80s than it is on an emulated hardware on a modern laptop. So he had plenty of time to read every task output and heuristics being applied to it and have some insights. So break and stop the program, examine, recompile, tweak heuristic, change the priorities on EURISKO's agenda, and explore. And hit the memory limits pretty soon, relatively speaking, in terms of task numbers. This virtual machine has 256 megabytes of RAM configured, which is, I believe, pretty much as much as the address space of Medley of the Interlisp system can permit. So that was a completely ungodly, unrealistic amount in 1980s. So he probably more had like 6-8 megawords. And that would be a quite slow process and fairly limited inroads in terms of tasks explored. What we see right now, we are on task 404, but probably that would take many days of running EURISKO on original hardware to get that far. This emulated version usually runs out of memory, runs out of heap space, or it runs into one of the couple bugs in the scheduler from what I see. I haven't explored much the source, but by the sound of it, that's it. And probably you can fix it when you get into debugger, but I'm not quite as familiar with the system. Either way, it's been completely fascinating to have it running right on my desk. I've read about the system since the 80s, and I always was fan of Dr. Leant's work, but never ever I expected to actually run EURISKO myself. So many thanks for good folks who done this outstanding work of computer archaeology, and to 704 for bringing up EURISKO on Medley and posting instructions for everyone how to run it, so we can actually relieve this process of using this extremely interesting programming artifact from the golden era of symbolic artificial intelligence, completely unlike the statistical AI, which is in vogue now, but nonetheless really important computer program, which also gave Leonard insights to start his seminal work on Psych, with founding of PsyCorp, and work that continues still apparently after his demise. So this is it, and you're welcome to see through for another 15 or so minutes, see how it explores the tasks. It slows down to human readable speed now, and gradually gonna be even slower. And yeah, enjoy.